it is impossible to comprehend the scale of the universe. But even though we have a potentially infinite space to look out to and measure, there are still some limits to what we will be able to learn. Now, physicists have warned we could be getting close to knowing everything we may ever know about certain traits of our universe, without ever understanding everything. We are used to pushing the boundaries of quantum physics, but the boundaries of cosmology might soon be in reach too, according to a new paper. The formation of galaxies and the evolution of the universe can be simplified down into a model that relies on just 6 numbers. That means if the Big Bang was to happen all over again, because of the consistency of these numbers, the universe would end up looking almost exactly the same. One can consider that the information contained in the data is compressed down to the combined constraints on these cosmological parameters, the researchers said. Ian Zema from the University of KwaZulu-Natal in South Africa and Douglas Scott from the University of British Columbia published a paper suggesting when we might hit a wall and be unable to find out any more about these numbers. Once we completely map out the three-dimensional volume of the universe with galaxy survey and neutral hydrogen survey, we will run out of universe to measure, co-author Ian Zema told, but there is a long way to achieve this, not in a short time scale, because currently we only map out a tiny fraction of the universe. Much of what scientists know about the relative contributions of dark matter and dark energy comes from the relic radiation left behind from the Big Bang, called the cosmic microwave background. We can measure the CMB by looking far into the distant universe. The most complete survey of the CMB was completed by ESA using the Planck Space Telescope in March 2013. Such precision puts tight constraints on the 6 numbers. If something like the density of matter in the early universe were different than we think, it would have made temperature patterns in the CMB that scientists haven't seen. Future measurements will be even more accurate than the ones we have now, locking the numbers in even more. But our measurements of the CMB can't improve forever, the researchers said. Information can only travel at the speed of light, meaning that if we look far enough away we can see events that happened in the past. Looking at the CMB, scientists have found temperature fluctuations, or anisotropies. Planck has already mapped a large fraction of the primordial anisotropies in temperature, said the researchers. Hence we are starting to reach the point where we are squeezing the CMB sky for the remains of the information. Experiments will always have uncertainties, but even if it were possible to measure infinitely precisely, the CMB can only reveal a certain amount. The researchers also pointed out all of the large-scale things we measure about the universe have the same behavior. They said there will always be some fundamental limit to how spread out the values of that thing can be, and that limit restricts how well we can nail down the numbers that describe the universe as a whole. We do not know how long we have before cosmology hits walls for all of the different ways of measuring the universe, but it will probably be a very long time, according to the paper. There's still a lot left to learn, the authors said. Future cosmologists will always be able to do better if they are inventive enough.